Bismillahirrahmanirrahim. Today I'm going to write a code that implements the binary search using an iterative as well as the recursive approach. These iterative and recursive means that in iterative we give a fixed point and we tell the code to run the code up to this point and to run the binary search algorithm up to this point. But while recursive call the function itself again and again. As we all familiar with this algorithm, which is binary search algorithm, it is basically an efficient algorithm for finding an item or an element from a sorted list. How? By repeatedly dividing the search range in half. How does it do? For example, I'll give you an example here. 1, 3, 6, 8, 9, 10, 11, 15. Okay, now this is a list. Now what does binary search do? The first thing you have to note is that it always implements, or it the search we perform, binary search we perform on an sorted array. The second thing we have to know that we have to divide the list in half into two parts. In the first time we have to divide the list into two parts, we will get the mid element. For example, there's a formula to find, like, the mid element. There will be the first element minus lower element divided by, I guess there's a formula. We will write the code and then we'll know the how the formula, like first plus second divided by 2, then we get the mid element. Now if we get the mid element 8 and our target element is 3, okay, the middle element is 8, so middle element is greater than the target element. So what will we do? We will update the previous, wait, what we have to do, we will update the previous this we will give them some names and all the. So and if the middle element is less than the target element, you have to update the first element, and if the middle element is greater than the target element, you have to update the last element. Okay, so I'll write a code here so that you can easily understand this. So first I have to make, because I'm implementing this code, binary search using both approaches, iterative as well as the recursive approach. So I'll make the method, first method will be of the iterative approach, you can say that simple binary search, and the other method will be the recursive approach, in which the this code or this function call itself its main body again and again. So def binary search, it will contain two arguments or two parameters, a list and an item. Okay, item, the target item, or target value, or target item or target value that I have to find. Wait, okay, now it includes like 2 points, or you can say the two labels that are the first and the last, that represent the current search range. The first will be the initial value and the last will be the list. For how that's how we say in arrays that the list contains n elements, so the last element will be the n minus 1. So last element, first element will be the initial element and the last element will be the L minus length of a list. list minus 1. Now I'll use while loop, and this while loop continues until the search range is valid. And when will be the search range, until when the search range will be valid? When the first is less than equal to last, the search range will be valid. It will break the loop when the first element will be greater than the last element. So we will use the while loop here. While first is first is less than equal to last. Definitely first will be the less than first will be less than last element, because the in binary search the list we take is the sorted list or sorted array. So if we will define the midpoint formula here, midpoint equals to first plus last divided by 2, and we'll use an if condition here which says that if a list midpoint is equal to an item, what we have to do is midpoint minus 1, and else first is equals to midpoint plus 1. Now what we are doing here, we are just saying that the while loop continues until the search range is valid. And when will the search range will be valid? When the first is less than equal to last. When first element will be greater than the last element, the loop will break down and we will go to the recursive function. Now we are saying that inside the loop we are defining the midpoint formula, which is first plus last divided by 2. These are the two elements, or you can say these are the two labels for defining the first and the last element. And we are saying that if the list contains the middle element, and middle element equals to, if the list middle element is equal to an item, the item we want to search, or the item we are searching for, we will just say that if that item, we have to update the last and the first point. We have to update these two elements as soon as we get the midpoint. So we are returning here return full. Simple. In the iterative approach, we are just saying that we are defining the two parameters, a list and an item, and we are just saying that first will be initialized with 0 and last will be initialized with that list minus 1. And we are just using the while loop, and we are just saying that the midpoint will be this, and if the list midpoint will be some element of the list, or if midpoint is some item from the list, update these 2 points, last and the first. Now we will just use the recursive function def binary search recursive. It will contain a list, an item, and these two elements as well, first and last as well. So first, last, and an item. Now we are seeing here, if length of a list is 0, we are saying that if the recursive function also implements the binary search, and we are just saying that it takes the same parameter as we used in iterative variant. The initial or the first case will be in recursive function will be the base case, and base case checks if the list is empty or not, and it checks if the list is empty, in which it returns. If it is empty, in that case it will return false. So if the list is empty, it will simply return false. Otherwise, in else, we are saying that we are again using the same formula for the midpoint, first plus last divided by 2, and we are saying if a list mid is equals to an item, then what we have to do, we will just return true. If the item or the target value we want to search comes in the list, comes in the middle value, we are just saying that you have to return true. You don't have to update the first and last. And just in the iterative case, what we did, we just updated the two values first and last, but in recursive we are just returning the boolean value true or false. We don't have to update the first and last, but before updating the first and last, we have to check the following conditions. So in else we will say if and we're just saying that if an item is less than a list of a midpoint. If the item we want to search, or the target value, is less than the middle point, as I told you earlier, what we have to do, we have to update the last element. Last less than. Okay, what we have to update the last is equals to midpoint minus 1. We have to update the last element, and we have to return the binary search recursive and the list, as well as the first, last, and an item. We have to return all these parameters of the binary search recursive function. In else, we are saying that update the first function. First is equals to midpoint plus 1, and return the binary search recursive function with all their parameters. Okay, now both iterative and recursive functions are called called with the target item 4, and results are printed inside the main function. So finally, in main block, a sorted list must be defined. Now we will define the sorted list inside the main block. We are saying that if name is equals to main, what we have to do, 1, 4, 7, 10, these are just list work. You have to give the space between the elements. 10, 14, 19. As you're seeing that the list is sorted, 102, 2 5 7 5 and take the list as you want. Okay, now print call the iterative method, which was the binary search function, and call the this list with 4. As I told you, we in both iterative and recursive functions, they are both called with the target item 4. We are saying that our target value is 4 and the results will be printed out. Binary search recursive. For recursive, we have to call the recursive method, recursive function, and the parameters that are used inside the recursive function, that are list. The initial or the first item or the first element will be 0, and the last element will be the length of a list -1. Just like we do in array, the total elements will be the n and the last element will be the n of n-1, and the target value we want to find is this. Now we will run the code. Return binary search. First, there's an error. It must be true. Why is it giving us a false? Else false. It must return true. Okay. An item, it should return true. Let me check. Length -1, and if first is less than equal to last, midpoint is equal to first plus last. Where if a list midpoint is equals to an item, then return true. Okay. Okay, before doing this, let me check. There is some mistake. Return true, and else if item is less than item, if an item is less than a list of a midpoint, then what we are saying that update the last is equals to midpoint -1, and in else update the first element, first is equals to midpoint. Now see, it's returned true because after finding the midpoint, definitely midpoint will be you can check midpoint will come 10. 10 is greater than the target value 4. In the next iteration, the midpoint will be 7. 7 is again greater than 4. So next time we check, we will get our target value 4. So it will return true in both. It will return true both times.